You got a friend in me.
Hey, algebra buddies.
You've got
Unit 3, Section 2. We're solving two-step equations here. Two-step equations. Remember, the inverse operations, we talked about them before. It's how you undo your equations. It's how you solve. You work it backwards. We have our four operations here: addition, subtraction, multiplication, division. The inverse, or the opposite. Remember, inverse means opposite. And opposite is opposite. All right, let's look at our first example. Here's how we're going to do it. You have to think of, I always tell my students, you think of this equation of, it's kind of like when you build a car, you have several steps, and then if you want to take the car apart, then you have to undo everything in the opposite order. So we have a little table here. I'm going to show you how we write it shorthanded, but it's basically, if we take this number x here, we don't know what it is, so we call it x. The first thing that we do to x in this equation was we divided by 2. And then we added 3. So you can see those two different rows right here. First we divided by 2, then we added 3. So if we want to work backwards and figure out what x was before we started this whole process, then we have to undo the last step. The last step was adding 3. First we divided, then we added 3. We need to undo that adding 3 by subtracting 3. So I'm going to show you the shorthand here. First we divided by 2, then we added 3. The opposite of adding 3 is subtracting 3. So I'm just going to write a little s there. The opposite of dividing by 2 is multiplying by 2. This is how the equation was made. Okay, first divide, then add. This is how we're going to take the equation apart and solve it for x. So this will tell you what you need to do first. You need to subtract 3 first, then multiply by 2. Let's see how that works. We're going to draw a line down the equal sign so we keep everything nice and straight. We have two sides of the equation are equal. As we said before, the first thing we need to do is subtract 3. So from each side of the equation, or each side of the line, we're going to subtract 3. And I always tell my students, you want to read this like a book. We read left to right. So just start up here in the top here, left. We have x over 2. That's just going to come down. There's nothing underneath it. So we're just going to write x over 2. We add 3 and subtract 3. They cancel each other. We have 19. We subtract 3. That's going to equal 16. And you notice where the line is, that's where our equal sign is. So here we have x over 2 equals 16. It's that simple. That's the end of the first step. Second step, we need to undo the division. So how do you undo dividing by 2? This is like the last section. We just multiply by 2, both sides. So we're going to get these 2's cancel. We're going to get x. Again, I'm reading it left to right. So they cancel. We get x coming down, the equal sign coming down. 16 times 2 is 32. And that's it. So I box it. Now, what if I want to go and check my answer? Well, if you want to check your answer, you have to plug it back in right here. So you take that 32. What's 32 divided by 2? 16. Plus 3, 19. That seems to work for us. All right, so that's how we're going to solve these equations. I'm going to reuse this little chart down here to figure out what was happening as we built the equation. We're going to undo it by working it backwards. We're going to go back up the table. Let's see the next example here. Next example is pretty close to the other example, except here we have the 3.2 in front. And you know that we can switch the order right here. The order that we add does not matter. Commutative property of addition. So I'm going to rewrite this equation first. I'm going to write it as x divided by 2.5 plus 3.2. All of that equals 4.6. And I have a little table over here that tells us what we did on x. The first thing we did was we divided by 2.5. Then we added 3.2. So that's the steps as they're listed here in the table. First step, divide by 2.5. Second one, add 3.2. The opposite that we're going to use to isolate x, or we're going to solve for x, we need to subtract 3.2. That'll undo the second step, and then multiply by 2.5. So line goes down the equal sign. We subtract 3.2 from each side. Minus 3.2. Draw the line, they cancel. So again, we read it left to right like a book. The x over 2.5 comes down. The 3.2 and the negative 3.2 cancel. The equal sign comes down. And we have 4.6 minus 3.2. That's going to be 1.4. So now what? Now we want to, we already did this, multiply each side by 2.5. So this becomes a one-step equation. It's just like the other equations that we just solved in 3.1. So they will cancel. You're left with x is going to equal, what do you get when we multiply all this out? 3.5? Decimal, ugly. That's what it is. X equals 3.5. So that's the second example. Well, what if they look a little different? Okay, like these here. Well, here you notice the division sign goes all the way over. So that's not actually what happens to the variable first. The first step, the division I'm talking about, the first step that we do if you plug in for the variable f here is you would add first. I'm going to write this up here. Now let's write it down here. We would add 2.5. And then what would we do? We would divide by 3. That's if we were plugging a number in and we wanted to work that all out to equal 2. Well, we don't want to work it all out to equal 2. We want to work it backwards. We want to solve for that variable there. So we need to do the opposite. The opposite of division is multiplication. The opposite of addition is subtraction. All right, so this is how the equation was made. This is how you're going to solve the equation. So this tells us we have to multiply both sides by 3 first. All right, I'm going to erase all that stuff there so we have room. So we're going to multiply both sides by 3. That's the first thing we have to do in this equation. Look, that's different than the last time, and it has to do with that division bar. They cancel. Read it left to right. So we get f plus 2.5 is going to equal 2 times 3 is 6. All right, so then the second step we have to undo addition. That's subtraction. So we subtract 2.5 from each side of the equation. So we read it left to right. F comes down. Here's a cancel. F is going to equal 3.5. Wow, 2 3.5s in a row. Unlikely. You try the next one. Pause the video. Try the next one all by yourself. Go! Okay, so I just started my little shortcut here. I look at x. The first thing we do is we subtract 1. Then we divide by 7. So subtract 1, divide by 7. The opposite of division is multiplication. The opposite of subtraction is addition. All right, I have that all done. This is how the equation was made. This is the way we need to solve the equation. So the first thing we need to do is multiply both sides by 7. So can I just move that thing here? Let's move that. All right, do that on your paper. It's a lot easier. We're going to multiply both sides of the equation by 7. Okay, these will cancel out. Now, again, it's like all the other equations. You read it left to right. What comes down is this part, x minus 1. So x minus 1 is going to equal 1 times 7, which is 7. So now we've done this. We need to add 1 to each side. So we add 1. We get x equal to 8. Circle it. Done. That's the second example. Last example. Let's look at this one. Okay, 16r minus 12 equals negative 4. So if I plug in for r here, we get, what do we do first? First we multiply by 16, and then we subtract 12. So the opposite of subtracting 12 would be adding 12, and the opposite of multiplying by 16 would be dividing by 16. So let's check that out. We add 12 to each side. Plus 12. Here's the middle of the equation. We have to be careful of our integers. So read it left to right like a book. So 16r comes down. We have the subtraction. When we subtract 12 and we add 12, they cancel. The equal sign comes down. Negative 4 plus 12 is 8. All right, now we subtract. Oh, no, not subtract. Now we're going to divide by 16, both sides. That's the opposite of multiplying. They're going to cancel. We get r equals 8 over 16, which you know is 1/2. So that is the last example of that type. Let's look at combining like terms. All right. When we combine like terms, we look at both sides of the equation. You should always combine like terms if possible. What does that look like? Well, it just means that you do subtraction and addition. Like these guys can go together. That's a negative 14 and a plus 4, positive 4. You can add those two together first. So before we start doing anything to both sides, this is like before you start solving. Actually, it's kind of solving in itself, but we're just simplifying here. We have a negative 14 plus 4. Remember that the sign in front of the number, to the left of the number, is the sign that goes with that number. So this is a negative 14. This is a positive 4. You just have to keep that in mind. So let's combine some like terms here. We get to 2x. There are no other x terms, so we're just going to bring that down. We have negative 14 plus 4. That's a negative 10, so I'm going to write minus 10. All of that equals 10. So now it's a two-step equation. We just learned how to solve that. First thing that happens, you multiply by 2. After that, you subtract 10. So the opposite of subtracting 10 is adding 10. Then we want to divide by 2. So let's do that. We add 10 to each side. Let's get that line down the middle. Read it left to right. So 2x comes down. The negative 10 and the positive 10 cancel. We have an equal sign. And we have a 20. Now, there's that step. We want to divide by 2. So divide each side by 2. We get x equals 10. We're done with that one. Let's try the second one. It's a little bit different because we don't have, these are called constants. We don't have constants that we're combining. These are regular terms with a variable here. We have a 2j and a negative 4j. What's 2j minus 4j? Or you can think of it as 2 plus negative 4, but I like 2 minus 4 better. That gives us a negative 2j. All right, the 10 comes down. There's nothing else to combine with a 10, and that's equal to 12. Okay, a lot of students will try to combine the 10 and the 12. You can't do that because they're separate. That's why we draw that line down the middle. They're on separate sides of the equation. You can't just throw them all together. Okay, they're different. They're on different sides of the equation here. All right, so what do we have here? We have a multiplication times negative 2, and we have adding with 10. So the opposite would be subtracting 10 and dividing by negative 2. So let's do that. Subtract 10 from each side. We're going to get negative 2j. Okay, I'm reading left to right. They would cancel. The equal sign. And we get a positive 2. Now we just did that. We want to divide by negative 2, so we divide each side by negative 2. And we get j is equal to negative 1. That is amazing. Algebra amazing. One last type here. Let's look at an application problem. Write out an equation for the function described. The output, we need to mark this here. So the output, that's important stuff. The output of a function is 8 more than 3 times the input. All right, now the input's normally x, right? And then the output is normally y. So y, the output is, all right, so y is 8 more than 3 times. We got to do 3 times the input. Here's 3 times the input. And then we want 8 more than that, so we add 8. Find the input, or find x, when the output, or y, is negative 1. So if you make y negative 1, that's what they're saying. They want you to find the input. This is a regular two-step equation. Let's look at it. What happens? Here's x. First you multiply by 3, and then you add 8. So the opposite would be subtracting 8 and dividing by 3. So the first thing we want to do, we want to subtract 8. Here's the line down the equal sign. Subtract 8 from each side of the equation. Draw the line. So we get negative 1 minus 8. That's negative 9. Is going to be equal to 3x comes down, and then the plus 8 and the minus 8 cancel. Okay, there's that step. Next step, divide by 3. So we divide each side by 3. We get negative 3 is equal to x, and we're all done. So the input, says find the input, so we're going to write that out. The input equals negative 3. So we've answered the question. Hey, that's it. We're all done with solving two-step equations. Coming up, even more steps. But let's master this first. Go through, do your practice. Make sure you check your answers. This is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. See you.
Darling, you've got a friend in me. Now some of the boys might be a little smarter than I am, or bigger and stronger too.